Welcome back. Okay, so in phase one, we absolutely nailed the internal network inside the customer's property. But today, we're stepping outside. Let's dive straight into this explainer on phase two, the access network, which is also commonly known as the last mile. We are officially leaving the building and stepping out into the physical territory where the real field magic happens. So what exactly is the last mile? When we talk about FTTH, or fiber to the home, we're talking about the purely fiber optic connection running directly from the customer's premises straight to the service provider's street infrastructure. This physical boundary is absolutely crucial. It's the essential bridge between the wider network and, well, the user's living room. And as a field technician, this specific layer is where you're going to be solving the most critical, and honestly, sometimes the most frustrating field issues you'll face today. Here's our game plan for today's explainer. We'll quickly trace the core network components, tackle two major roadblocks, high optical attenuation and total drop cable failure, and then wrap up with a master checklist that you can take right into the field. All right, part one, core network components. Look, before you can fix a fault out there, you've got to be able to map out the physical path you're tracing. You literally can't fix what you can't trace, right? So the physical path of our last mile starts right at the customer's wall box. We call this the FAT box, or fiber access terminal. From there, we follow the drop cable. That's the rugged, heavy-duty black fiber cable running along the street. Maybe it's underground, maybe it's strung overhead on poles. Finally, that cable ends up at the local neighborhood hub, otherwise known as the ODF or street cabinet. It's a pretty straight line, sure, but there is a lot of rough physical terrain where things can go wrong. And get this, 90%. A staggering 90% of all outdoor network faults happen right here along that exact physical path we just traced. That means if you master this single stretch of cable, you're going to solve almost every headache you encounter out in the weather. Moving on to our first major issue, high optical attenuation. High attenuation is just the technical term for when a customer frantically calls in because their internet is crawling or worse, just dropping out randomly. Picture this. You get on site, you pop open the enclosure, you plug in your optical power meter, and bam, minus 28 dBm. On most meters, this will literally be flashing red at you. It is a critical warning. When you see a severe signal drop like this, you know the light is struggling to make it through the fiber. That customer's connection is barely hanging on by a thread. So, the million-dollar question, why is the signal dropping so hard? In the last mile, severe signal loss almost always boils down to one of two physical culprits. On one side, you've got microscopic dust hiding inside those physical fiber connectors. On the other side, you've got macro bends. That happens when your rugged outdoor cable gets sharply bent or pinched way too tightly inside an enclosure. Luckily, there's a rock-solid, direct protocol to diagnose and cure this attenuation right on the spot. Here's your three-step fix. First, one-click connector cleaning. Second, the VFL laser test. And third, slack management and straightening. Let's break exactly how to execute these so you're ready for the field. First up, dust. It is literally the invisible enemy of light. Your absolute first move should always be pulling out your professional one-click fiber cleaner and using it inside the fat box on the customer's wall. So often, just clearing away these microscopic particles that you can't even see with the naked eye will completely restore that signal path. But hey, if the signal is still weak, we move to step two. Grab your visual fault locator. This tool is awesome. It shoots a highly visible, incredibly bright red laser right down the core of the fiber. As you trace along the drop cable, you're literally looking for a glowing red leak. If you see bright red light shining straight through that thick black jacket, you just found your problem. That red glow is the actual data-carrying light escaping from a microcrack or a sharp macro bend hiding inside. Once you spot that leak, the fix is step three, slack management. You're going to carefully straighten out that pinched cable and arrange it inside a proper slack loop box to relieve all that tension. Do that, and you get the absolute best reward a technician can ask for. You'll watch your power meter jump right back up to a perfectly healthy minus 18 dBm. The tension's gone, the light is flowing completely clean, and your customer is back online. Okay, let's switch gears to part three, total drop cable failure. Sometimes you aren't just dealing with a pinched cable, you're dealing with a totally destroyed one. Because drop cables often run overhead on utility poles, they're constantly fighting the environment. Heavy windstorms, massive falling tree branches, wildlife, you name it. When one of these hazards physically snaps a drop cable, the light just cuts completely. Zero signal. And that instantly triggers a terminal alarm for the customer. Loss of signal, or LOS. The physical link is totally down. When you're staring at a completely snapped line, there is a very clear right and wrong way to proceed. Trying to tape it up or patch that broken cable right there in the middle of the street? That's simply the incorrect fix. It won't hold up to the weather, and it definitely won't provide a clean light path. The true professional standard, really the only acceptable solution, is a complete drop cable replacement.
Here is exactly how you execute that professional replacement. Step 1, pull a fresh, heavy-duty reel right off your field truck. Step 2, safely run that new line along the utility poles, or pull it cleanly through the underground duct. Step 3, terminate the end at the neighborhood FDT box. You'll use a pre-terminated mechanical connector or a rugged outdoor splice closure for this. And finally, Step 4, always test the new light path to guarantee a clean, uninterrupted link all the way from the cabinet to the customer's home.
Which brings us to our final section, the last mile master checklist. Let's lock in this knowledge. Before I just hand you the checklist, I want to challenge you. Let's do a quick diagnostic quiz straight from the field scenarios. Imagine you're out there, you plug in, and your meter shows a critical drop of -29 dBm. What are the very first 2 things you inspect? Take a second. Think about those 2 villains we talked about earlier. Did you guess it? Yep, the correct answers are right here. Number 1, check for microscopic dust inside the optical connectors. And number 2, check for a sharp pinch or macro bend somewhere along that cable. Those should always be your immediate prime suspects when you're dealing with severe signal loss in the last mile.
And that brings us to your final actionable summary. Make this your daily ritual. First, always bring your power meter and fiber cleaners to outdoor boxes. Seriously, don't even open an enclosure without them. Next, rely on your VFL red lasers to easily hunt down those hidden cracks and bends along the street. And lastly, keep your drop cables properly organized in slack loops to protect them from weather tension. Ultimately, managing the access network is all about protecting that physical light path at every single turn.
And that wraps up today's explainer. Honestly, congratulations on tackling some seriously intense field concepts today. Get ready for phase 3, because next time we're moving deeper into the city infrastructure to explore the metro and aggregation networks. You've mastered the building, you've conquered the street. But what happens when hundreds of these individual street connections merge into one single massive city artery? If a single cut completely blacks out 1,000 homes, are you ready to trace that source? We'll find out next time.